So property 4 is called 1 by x property. So the formulas that you have in this property is sine inverse of 1 by x is equal to cosecant inverse of x. So if you convert sine inverse into cosecant inverse, the argument gets reciprocated. Similarly, cosecant inverse of 1 by x is equal to sine inverse of x. Cos inverse of 1 by x is equal to secant inverse of x. Secant inverse of 1 by x is equal to cos inverse of x. And tan inverse of 1 by x is equal to cot inverse of x. And cot inverse of 1 by x is equal to tan inverse of x. All these are good, but these properties hold good for all values for which these are defined. But tan inverse of 1 by x is equal to cot inverse of x. Cot inverse of 1 by x is equal to tan inverse of x is valid if x is positive. That is, if x is greater than 0. If x is positive. Tan inverse of 1 by x is equal to minus pi plus cot inverse x if x is negative. That is, x is less than 0. Similarly, cot inverse of 1 by x is equal to pi plus tan inverse of x if x is negative. So if x is negative, you have separate formulas. So tan inverse of 1 by x is equal to minus pi plus cot inverse x. Cot inverse of 1 by x is equal to pi plus tan inverse x. So let us look at the logic behind these formulas. So let us try to derive this property. Sine inverse of 1 by x is equal to cosecant inverse x. So how do you convert from one inverse trigonometric ratio to another inverse trigonometric ratio? So first we start with let sine inverse of 1 by x is equal to theta. So let sine inverse of 1 by x is equal to theta. So if x is positive, theta lies in the first quadrant. If x is negative, theta lies in the fourth quadrant. So now this implies, so if you apply sine on both sides, sine of sine inverse of 1 by x is equal to sine theta. So sine of sine inverse 1 by x, as long as 1 by x is in between minus 1 and plus 1, these two gets cancelled. So 1 by x is equal to sine theta. So this implies x is equal to cosecant theta, 1 by sine theta. This implies cosecant inverse of x is equal to cosecant inverse of cosecant theta. Now as we have seen, for positive x, theta lies in the first quadrant. For negative x, theta lies in the fourth quadrant. So wherever theta lies, theta is in the range of cosecant inverse. So these two are getting cancelled. So theta is equal to cosecant inverse of x. And theta is also equal to sine inverse of 1 by x. So sine inverse of 1 by x is equal to cosecant inverse of x. So a similar derivation can be thought of for cos inverse of 1 by x is equal to secant inverse of x. Because both the ranges are same, so you get exactly the same derivation. Now let us go for derivation for tan inverse of 1 by x. Let us see why you get two different formulas correspond to positive x's and negative x's. Let us look at why there is a difference in the formulas for negative values of x. If x is negative, tan inverse of 1 by x is minus pi plus cot inverse x. And cot inverse of 1 by x is pi plus tan inverse of x. First, let us try to understand this using the quadrant diagram. So if you draw the quadrant diagram for tan inverse. So tan is positive in these two and negative in these two. And the range of tan inverse is minus pi by 2 to pi by 2. Now, if x is negative, obviously 1 by x is a negative number. So if a negative number goes inside tan inverse, the answer will be in which quadrant? The answer will be in the fourth quadrant. That is, if x is negative, tan inverse of 1 by x is in the fourth quadrant. That is, this is a negative angle in the fourth quadrant. Now, cot inverse of x. If you take cot inverse of x, because x is negative, so a negative number is going inside cot inverse. So obviously you get an angle in the second quadrant. Because the quadrant diagram for cot inverse is something like this. Plus, minus, and the range is from 0 to pi. So if a negative number goes inside cot inverse, you get an angle, you get an answer in the second quadrant. But tan inverse of 1 by x and cot inverse of x have to be allied angles. They have to be allied angles. So if you draw both the diagrams on the same diagram, so tan inverse of 1 by x is an angle here. Cot inverse of x is an allied angle to this angle in the second quadrant. So this side is something like, for example, if you get minus pi by 3 here, if this angle is minus pi by 3, cot inverse of x will be its allied angle, which is 2 pi by 3. So from 2 pi by 3, if you want to get minus pi by 3, what should you do? So from cot inverse of x, you have to subtract a pi. From cot inverse of x, you have to subtract a pi so that this value becomes equal to tan inverse of 1 by x. Similarly, do the same thing for cot inverse. Now if x is negative, 1 by x is negative. So cot inverse of 1 by x, because the range is from 0 to pi, this angle is in the second quadrant. And tan inverse of x, because x is negative, is in the fourth quadrant. You get an angle. The LHS is an angle in the second quadrant. RHS is an angle in the fourth quadrant. But these two angles are allied angles. Hence, what should you do to get this angle here? So to get this angle here, you have to add a pi. So here you have to add a pi. For example, if you put 1 by x is equal to minus root 3. So if 1 by x is minus root 3, that is x is minus 1 by root 3. So cot inverse of minus root 3 is pi minus cot inverse of root 3. So cot inverse of root 3 is pi by 6. So pi minus, you get 5 pi by 6 as the answer. Now tan inverse of minus 1 by root 3 is minus pi by 6. So what should you do to get this 5 pi by 6 from minus pi by 6? You have to add a pi. So I hope you understand what we are dealing with in these formulas. So you just need to make sure that the LHS and RHS are equal. And you can add a pi or subtract a pi because we are dealing with allied angles. So what are allied angles? We have discussed that in the chapter of trigonometry. So now we'll go forward to the further properties.